And before we get into rates too much, I just want to clarify what ratios are first, because they say that a rate is a form of ratio. So let's just quickly review what ratios are. I'll just give an example here on this slide. So if I could say something like the ratio of 5 to 2. Does anybody know what that would look like as a fraction? The ratio of 5 to 2, if we were to write that as a fraction? Alexandros, yeah. So you write the ratio of, right, top thing to, right, 2, and then put the other thing on the bottom. So the ratio of 5 to 2, we could write that as a fraction 5 divided by 2. Excellent job, everybody. Okay. So basically, a rate is a form of ratio in which you've got some kind of unit of measurement on the top part of your, right, the top piece of your ratio, and you've got some other unit of measurement on the bottom piece of the ratio. So let me just use our example from here, the ratio of 5 to 2. I could say something like $5 per 2 gallons of gasoline. Okay. And so we could write this as, right, we could write this as a ratio of 5 per 2. That would be 5 over 2. 5 divided by 2 is earlier. But, right, we can actually go further here. We can use units of measurement. We're told that, right, it's $5, and that's for every 2 gallons. So the difference here between what we have at the top and what we have on the bottom, right? The thing on the top here, the 5 over 2, is just a general ratio. The thing here on the bottom, $5 for every 2 gallons, this is more specifically a rate because we have different units of measurement on the top and bottom pieces of our fraction. Oh, Debbie, yeah, that's another way you could write it. You could, instead of the fraction bar, the division bar, you could also use that little colon dot dot. So I could actually add that to my work up here if I wanted to. Yes, you could have like 5 is to 2. That's also correct. Good question. All right. More questions, please let us know in the Q&A, everybody. Now, we've talked about ratios, we've talked about rates. Now let's talk about the unit rate in particular. The unit rate is the amount of the thing on the top per 1 unit of the thing on the bottom. So, in my example, let me just, oopsie. I'm going to quickly copy this here, and I'll bring it down. So if I go with my original rate of $5 per 2 gallons, right, to figure out the unit rate, what we want to get this thing in terms of is per 1 gallon. Okay. Again, if you have questions, please let us know in the Q&A. It's a separate button in Zoom from the chat. Okay. Asking questions in the Q&A, that way fellow teacher Benji will be able to help you there. All right, Tyrese, yeah. Right, so Tyrese, what you're doing, it sounds like, is you're taking 5 divided by 2. You're doing the math here, right? 5 divided by 2, and that gives us 2.5. Yeah, so I can basically simplify the 5 over 2. I can make it 2.5, right? And that's going to be, again, in terms of dollars per gallon. So we've got $2.50 per 1 gallon of gas. Okay, so you just take 5 divided by 2, you get 2.5, and you're keeping the same units on the top and bottom. We're still going to have dollars on the top. We're still going to have gallons on the bottom. Okay, but this isn't just a rate, any rate, right? This is specifically the unit rate because it's something per 1 unit on the bottom, one, in this case, 1 gallon of gas. All right. So we can also graph what we just had here, right? So here we've got gallons of gasoline, and we get the cost. So we can see that as we get more gallons of gasoline, the cost of all that gasoline increases. And here are some data points on the graph. Now, question for you all. Let's use these 2 points. Has anybody here ever had to calculate the slope of a line? Anybody do that yet in your GED math or outside the GED? Yeah. Okay. Yeah. So to calculate the slope of a line, right, you can take 2 points that are on the line. So I'll do that down here. Right, you take the difference between the y values. So in this case, we'll take 12.5 minus 7.5. That's because the y values, right, the vertical step, that's cost. Okay. So let me put this over here. So we get $12.50 minus, right, $7.50. All right. And then I'm going to extend this line a little bit here. Here we are. All right. And what would I want to plug into the bottom of my slope formula here? If I have 12.5 minus 7.5 on the top, then in terms of gallons, what would I have on the bottom? Would I have 5 minus 3 or 3 minus 5? Yeah, we have to have 5 minus 3 because we have to be consistent here. Yeah. So 5 minus, oops, 3 gallons. Okay. And what does this simplify to? What does the top become if we do the subtraction? The hybrium? Yep. 12.5 minus 7.5. Okay. That gives us $5 on the top. Okay. And then on the bottom, we have the 5 minus 3. Right. So that's going to give us 2 for gallons. And notice what we just did. We calculated the slope of this line, right? That's the rate of change. For every $5 we spend on gas, right? That's for every 2 gallons of gas. And that gives us the same rate that we got earlier. And we can even simplify this further. We can, again, take 5 divided by 2 to get $2.5 per gallon of gas. So these are just different ways of looking at the same kind of information, right? You can use the graph by finding the slope. You can, right, plug in to make a ratio or a rate, right? Again, just different ways of understanding this information. All right, nice job. All right, I want to give you a practice question to try now so you can practice your rate-related skills. For this next question, Benji, maybe please get 2-minute timer. And this, everybody's just a multiple choice question, A through D. All right, so 2 minutes to see what you can do with this rate-related scenario, and then I promise we'll review. Go for it. Okay, everybody, we'll come back together and review your work on this question. If you've not had a chance to take our poll yet, I encourage you to do so now as we start reviewing together. So this question wants to know the rental cost per hour. Okay, so cost per hour, is that a rate? Actually, right, it is a rate, Edie, because cost per hour, right? That's basically you take one kind of unit of measurement, which is cost, and you divide, right? Per means divide by hours, which is another unit of measurement. Yeah, so we have one unit of measurement divided by another unit of measurement. That is definitely a rate. And let me actually tighten this up on the slide so we can just focus in on that, right? We want a rate cost per hour. Okay. Well, we know the cost for the amount of time, right? It's $20.84. But in terms of figuring out hours, how did you get the number of hours here from 9 a.m. to 4 p.m.? Right? Because that's what we need for the rate. We need the amount of time. So how did you get the amount of time from 9 a.m. to 4 p.m.? Roland, you counted? Okay. Yeah. Right. Just count from 9 a.m. to 4 p.m. You can do that. All right. So that's going to be 7 hours, as some of you have mentioned in the chat. Okay. And so we'll take our amount of money, right? Cost $20.84 per 7 hours. And so when we do that math, we get $4.12 per hour. Is that your? Yep. And that looks like that matches choice C, which is correct. Great work. All right. So um, with a rate question, just make sure that you are plugging in things in the appropriate place. Here, cost per hour means we take cost divided by the hours. Easiest question for tonight. Okay. Yeah, for some of us, this might have felt a little easier. Some of us, maybe not so much, right? It just depends on kind of where you are personally with your GED math prep. But this is, right, this session certainly has a lot of math topics. So lots of data analysis related topics in GED math. So great work kicking in there. Um, Speaking of which, we are actually coming up to our final math topic for this session, right, for data analysis, which is probability. Okay, so we'll look at probability now. And probability also involves a formula to get familiar with before test day. All right, so